Hi everyone, I'm Dr. Prasad Puthiyillam. Back to my class series on chemistry for computer science engineering, Technological University, with the subject code BCHES102. This is continuing module 1, part 5. Okay, I'm including important points. Actually, I'm including revised Bloom's taxonomy level 3 and 4, mainly 3 and 4. I'm not considering 2. They are we are discussing in regular classes. Considering 3 as well as 4 level questions, which will be useful for students for higher studies when they go. It could be having more use at the higher studies to do some project and so I tried to incorporate a higher and questions and their answers. So this particular class I am explaining only electrochemical gas sensors. Okay, the previous whatever it is already explained and it is available in my YouTube channel. And continuation of electrochemical gas sensor for SOX and NOx separate video I'll be making in detail. So only covering electrochemical gas sensors. So electrochemical gas sensors, some of the possible questions only based on electrochemical gas sensors given here. What is the working principle of electrochemical gas sensor? What are some of their advantages and disadvantages compared to other sensing technologies? It's a level 3 question. Can you explain the sensing mechanism of electrochemical gas sensors and how do the sensor material and design affect the sensor performances? How can electrochemical gas sensor can be calibrated and characterized, and what are the main factors that affect their accuracy and precision? Level 4 question. Discuss the limitations of electrochemical gas sensors in terms of selectivity, sensitivity and stability, and explain how these limitations can be overcome. Level 4 question. So here in these two level questions, I didn't use the term that is analyze or evaluate or but still the needed knowledge comes to that level. So point under to answer those questions, I put many points. Electrochemical gas sensor, it can detect a wide range of gases, including toxic or flammable gases such as carbon monoxide, hydrogen sulfide, or methane at low concentrations. Okay, so these are very dangerous gases if it is if you send them free to the atmosphere. They are not so friendly to us. Therefore, we need to identify those gases, even if it is a low concentration. Even if it is low concentration, also we have to identify and we have to do some cure. Okay, so in general, electrochemical gas sensors, the structure, the schematic representation can be represented like this. This represents the gas, any gas that you want, any gas that you want to sense. It is connected to a membrane, and the membrane is having sensing electrode attached to that. And then electrolyte is there, then a counter electrode, a reference electrode is mainly, then the remaining circuit. There is also a temperature sensor maintained because gas, you know, at a small variation in temperature, the property of gas will vary, and the sensing, the pressure will vary. Then our measurement will be affected with that. Therefore, we have to check a particular temperature or what is the concentration of that particular gas. So this is just a schematic representation. In actual practice, what is available in market, they are using this concept, but there will be different designs they are using. Okay, so working principle and sensing mechanism. Electrochemical gas sensors are based on the principle of redox reaction. So that is the chemistry behind that. Between gas molecules and the sensing material at the surface of the electrode. These sensors electrode is typically made of conductive materials such as platinum or gold or carbon and coated with a sensing layer that can selectively absorb or react with the target gas. Okay, so anyhow we need a conductive material because it is an electric circuit. The electron movement should be there, therefore a conductive material needed. Platinum and gold are used because they are highly conductive. They are even somewhat resistant to other reactions. Therefore, platinum gold is preferred. Even they are having the very good catalytic property with the platinum and gold. Carbon is also a very good conductive material, but it is not having that much catalytic property. But it can be used by having that oxygen and nitrogen attached functional group. If it is attached, it can be a very good replacement to platinum and gold, because it is comparatively cheap compared to platinum and gold. We know the cost of platinum and gold. Okay, so these the electrode potential changes when the gas molecule are either oxidized or reduced by the sensing material, resulting in a measurable electrical signal. Therefore, the gas that you want to measure or want to sense, either it may undergo oxidation reaction or it may undergo reduction reaction. Either oxidation or reduction reaction, it involves the electrons. The electrons are there, we can take it outside the through the circuit, and we can measure it accurately. Based on that electrical signal, we can say how much is the quantity of gas present. For example, to sense the carbon dioxide. Okay, carbon dioxide, we are much worried about carbon dioxide. Okay, we will measure carbon dioxide. I seen some of my student friends doing working on carbon dioxide gas sensor. Okay, so it needs a platinum or gold coated with carbon dioxide sensing material, usually a metal oxide such as tin dioxide or tungsten trioxide is used as the sensing material. And the electrode, we are not using tungsten as such as an electrode. Electrode is made up of platinum or gold or any carbon graphite coated catalytic coated one, and over that we are using tungsten trioxide or tin dioxide can be used as even nano sized also give better performances. It can be used as the sensing material. Now, the reaction for the detection of carbon dioxide in an electrochemical gas sensor, it will vary with the material that we use, and therefore the reactions, different reactions we have to consider. Carbon dioxide adsorption reaction. Carbon dioxide has to be adsorbed onto the surface of the that membrane or the material electrode. Then only reaction takes place. The electrode cannot go behind carbon dioxide and getting the reaction. You have to attract the carbon dioxide to the surface. You should absorb that, not simply going here. It should go and sit for a moment. Then only it can we can make them to react. Therefore, adsorption of carbon dioxide on that surface of electrode is one of the criteria. Then reduction. Once it is absorbed, then our agents will start working. They will do the necessary reactions, oxidation or reduction reaction. So it reacts with the absorbed carbon dioxide molecule reacts with the electrons from the working electrode to form a bicarbonate ion and hydroxide ion. That is HCO3 minus and OH minus. That is the reaction is given CO2 plus 2 electrons plus water molecule moisture gives a HCO3 bicarbonate ions plus a hydroxide. Okay, so detection. So we got some changes. Bicarbonate ion is formed, hydroxide ion is they are generated in the reduction reaction. It will generate a current or voltage signal which can be detected, indicating the presence of carbon dioxide in the sample or in the atmosphere where we are using the sensor. So that is generally given. The sensing material is a critical component for a sensor, and its design can significantly affect the sensor performance. Therefore, which is sensing material we are using, not even the electrode. The material that we are using to coat on that, which is the sensing material, and the design of that, how it is designed, how it is attached to that, gives varies the performance of the sensor. Various materials such as metal oxides, polymers, biomolecules have been used as the sensing material depending on the gas target and the sensor requirements. So just now we seen only carbon dioxide sensing. Many gases are there. We need to that it has to be sensed. So based on that, we have to vary the material that we are using. The selectivity of the sensing material can be enhanced by adding specific functional group that can interact selectively with the target gas. Yeah, that only I said. It depends upon the gas and the functional group present in the sensing material. For instance, a metal oxide can be doped with different metal ions or functionalized with specific groups such as carboxylic acid or amino acid groups to improve their selectivity towards target gases, because amino group or carboxylic acid groups they can absorb, they can immediately capture and do the required reaction. For that, the sensing material can be even doped. Doped means added. The carboxylic acid functional group or amino acid functional group are added. What is carboxylic acid functional group? You may be knowing that is COOH. amino group NH2 group. Okay, that is added to the metal oxide sensing material that we are using. Then there is an improvisation of the sensing mechanism. These the sensing materials morphology and structure can also play a critical role in sensor performance. Materials morphology means the surface nature. Okay, what is seen not by seen in our eye, what we can see with the microscopic level. What is the morphology, how they are arranged, that gives because the gas molecules are not bigger one, they are very small. Okay, so the surface of the sensing material that we are using, not my hand, just taking the example, the surface of the sensing material that we are using, its morphology, that is to that size of that gas molecule which is used. How, what is the arrangement of that the sensing material, that as well as the structure will play not play, play a very critical role in sensor performance. The surface area, a porosity, a crystallinity of the sensing material can affect its sensitivity, the response time, and the stability. Sensitivity means how much fast response, how much how it sends a particular gas that you are targeting. Response time, in what time, how fast it gives the result. Stability, how long we can use that material sensing, if it is kept in a fixed position, how long it can be used, that sensor. These are all depending upon the surface area, porosity, and crystallinity. For example, a high surface area sensing material can offer more active sites for gas absorption, leading to increased sensitivity, while a porous structure can enhance gas diffusion, reducing the response time. That means if it is a pores are there, then when gas will go inside, whether it is sensed or whether it remains there, that will affect the response time. Okay. Hello PPT. Okay. Furthermore, the electrode design, such as the size, shape, material, can affect the sensor sensitivity, selectivity, and response time. Okay, already explained it. For this instance, smaller electrode size can improve the sensitivity response time by reducing the diffusion distance of the gas molecule, while a specific electrode material can offer better electrocatalytic activity for the redox reaction. So electrocatalytic activity. So catalytic activity, we know, speeding up the reaction. Catalysts are used. They are having electrocatalytic activity. Advantages and applications. So what are the main advantages and applications of electrochemical gas sensor? Electrochemical gas sensors have several advantages, as we say general, over other gas sensing technologies, including high sensitivity, fast responses, and low power consumption. Electrochemical gas sensors are widely used in various applications such as industrial safety, environmental monitoring, and medical diagnostics. So industrial safety, we are doing so many good things in our industry, so-called good things only. One way we have to, for our convenience, there the people who are working, they should have some safety. For that we should have a sensor there. Environmental monitoring, okay, because of that only pollution is there. Okay, that also we have to monitor. So environmental monitoring also we need sensors. Medical diagnosis, that anyhow we are taking that continuation of that environmental pollution, so many medical issues, so we need to monitor that one also. Why we want to do all this? Better to go back to forest. Okay, I'm not continuing that topic. While electrochemical gas sensors have many advantages, they also have some limitations that can affect their performance. Okay, they have limitations also. Okay, we'll see the limitation factors affecting. What are the factors which affect the performance of electrochemical gas sensors? The accuracy and precision of electrochemical gas sensor, it can be affected by several factors such as the quality, the stability of the sensing material, the sensor design, and the environmental conditions. The sensitivity and selectivity of the sensing material can be affected by aging contamination, or exposure to high temperature or humidity. There is no aging contamination. Aging is a separate word, contamination is another word. As well as exposure to high temperature, humidity. The sensor design, such as the electrode size and geometry, can affect the diffusion rate of the gas molecule and the electrochemical reaction kinetics, leading to changes in the sensor's response. No much to be explained. Same thing, geometry only, a word which was something complicated, but nowadays geometry is not a complicated one. Moreover, the environmental conditions such as temperature, pressure, and humidity can affect the gas diffusion and the electrochemical reaction, leading to changes in sensors response. Temperature we need to consider, pressure we need to consider, humidity we need to consider. That means we should have a temperature sensor, a pressure sensor, as well as humidity sensor. Okay, that is the point behind that this sentence. We should have separate sensor for temperature, separate sensor for pressure, as well as humidity. Then we can have the electrochemical gas sensors. Okay, so they are available now, so no need to worry. To improve the accuracy and the precision of electrochemical gas sensors, these factors need to be carefully considered and controlled, and the sensors need to be regularly calibrated and characterized against the target gas and interfering gases. That means we need to keep on checking the effectiveness of the sensor with the non gas concentration or non gases, with the non temperature, pressure, humid conditions. We need to check whether we are getting the reproducibility or we are getting the value which is actually needed to be given by the sensor. Calibration and maintenance, how to do that. Oh. The calibration and maintenance of electrochemical gas sensor are critical for ensuring the accuracy and reliability of the measurement, as well as the longevity of the sensor. Okay, complicated words are not there. Longevity means a long term usages. Accuracy, that is perfectness. Reliability means how much we have to rely on that. That are depending upon the calibration and maintenance. Can be calibrated and characterized by exposing them to a known concentration of target gas in a controlled environment and measuring the response. Simple sentence. The calibration process involves determining the relationship between the sensor's response and the gas concentration, which can be expressed as a linear equation or non-linear equation. But if you have a graphical mean, that we usually say, if you have a particular graph, of using the graph, it is very easy to detect the other calculations. So it can be expressed as a linear or non-linear equation. We need to have something that if a particular gas particular concentration, how much should be the reading has to be indicated, which we can use to do the calculation. The calibration process should be repeated periodically as the sensor's performance can change over time due to various factors such as sensor aging, environmental conditions, and exposure to interfering gases. Therefore, a repeated calibration is always needed. You cannot simply keep a sensor somewhere and just leave it. We have to, in time period, we should take it out and check for its accuracy. Additionally, the sensor selectivity and cross reactivity should be tested against other gases that may be present in the target environment. Okay, so there is a possibility that not only one gas extra, the other gases, which is when we install the gas sensor to a particular room, there may be some additional gases that we understood and we kept the sensor. After some time, they may change it. Okay, so that also we have to keep it in mind. Just an example is given. So based on the not only the target gases, the other gases present in the environment also, we need to have knowledge about that, and possible cross reactions we should think about that. That is a train. Limitations and solutions. One of the main limitations of electrochemical gas sensor is their selectivity, which refers to their ability to distinguish the target gas from other gases that may be present in the environment. We only said that selectivity is very good one. The same thing is also one of the limitations. Okay, selective. We should have, it should have a very good selectivity. Right now, whatever gas sensor we have not having exact selectivity. It is not selectively identifying the gas that of our target. The other gas interference also there. Electrochemical gas sensors can be affected by interfering gases such as water vapor, carbon dioxide, and other volatile organic compounds, which can affect their accuracy and reliability. As a water vapor is one of the main thing which is affecting our normal electrochemical gas sensors, because moisture it varies, and it is something electrochemical something, so we need some atmosphere which is watery atmosphere also needed for the reaction to work properly. and these water vapor excess water vapor present in that, mainly the humidity, it will affect. Then carbon dioxide will affect, and other volatile organic compound which present, they may even destroy our sensor. Another limitation of electrochemical gas sensor is their sensitivity, which refers to their ability to detect low concentration of the target gas. Okay, how much low concentration ability to detect our gas sensors are having some limitations in there also. The sensitivity of electrochemical gas sensor can be affected by various factors such as the quality and stability of the sensing material, the sensor design, and the environmental conditions. Okay, so the material that we use as a sensing material, mainly as I said, tungsten trioxide, tin oxide, lead oxide are used mainly. So their the quality of stability of the material not at 100%. See, though we are using it, still scientists are searching for alternative option for that. So and the design, we could not even still design a proper one to get a maximum usage of the material, and the other environmental conditions also affecting. So those are the, limitations. High concentration of target gas can also affect the sensitivity of the sensor and cause it to saturate or degrade over time. So if it continuously the sensor is getting a high concentration of the target gas, then obviously the sensitivity will be affected. Finally, the stability of the electrochemical gas sensor can also be a limitation, as the sensing material can degrade or change over time due to various factors such as aging, contamination, or exposure to high temperature, humidity. To overcome these limitations, or solutions also needed now. Okay. To overcome these limitations, several strategies can be employed, such as optimizing the sensor design, using multiple sensors for different gases, using signal processing techniques to reduce the effects of interfering gases, and developing advanced materials and encapsulation techniques. That means many other sensors are in connection. You always said temperature sensor needed, pressure sensor needed, humid sensor needed. All these are should be there along with that to get to understand what temperature, what pressure, what humid condition it is done, as well as many other sensors also needed to identify the gases. So everything connected, integrated one will be giving a better result. The stability of electrochemical gas sensors can be improved by using a more stable sensing material such as metal oxide or carbon nanotubes, or by using protective coatings or encapsulation techniques. That is to increase the stability of the gas sensor. Additionally, regular calibration and characterization of the sensor can help to ensure their accuracy and reliability over time. That means we have to take out the sensing material and we have to characterize what is happened to that. Not simply taking out, and you have to check what is happening, what any changes happened or not. We have to check. Then only we can go for any changes if it is needed. Recent developments in electrochemical gas sensors include the use of advanced materials such as two-dimensional material or metal organic frameworks, and the integration with the wireless communication, integration with data analysis platforms for the real-time monitoring and decision making. Okay, so these things everyone right now, the new generation, they can able to understand what is data analysis, what is wireless communication. Metal organic frameworks I'll explain. The future of electrochemical gas sensor is promising as they continue to offer new opportunities for sensing in harsh and complex environments, and for addressing emerging challenges such as air pollution, climate changes, and public health. Okay, metal organic frameworks, they are made up of some of the organic metal oxides having porous in nature. They used for applications mainly in now detection of sulfur dioxide detection, nitrogen dioxide detection. They are mainly used. So please do subscribe and support to my YouTube channel, My Intuition 4865. So thank you very much.